Right, welcome back. So the plan for today is to continue with our WASM project, and I was thinking of trying to implement the printf functionality that we discussed before, right? And I've already tried to do that like yesterday, but I won't post that video because it was really long, and I actually managed to get to some result, which worked fine, but I was like, it's kind of a bit too complex, or I mean, it's a bit too much code to write. And actually, in the end, I managed to get it to like something decent using string builder. So I managed to also get string builder to work fine with WASM, and we can actually build a string, right? Exactly as we do in C. We'll look a bit over how I did that, and then we can print it with sister with this function, which I was thinking of trying to actually add variadics to this function instead, because then it would be just a single call, which is much better. So let's look a bit at how I got this one to work actually. So inside of wasm.h, as you know, we have all of these function. It's like a header, and I thought, well, if we are trying to compile ds.h to wasm, maybe it actually makes sense that wasm.h is kind of like an extension to ds.h, so we can add wasm implementation like define here, and then we'll define all the flags that we need for ds.h to like work on WASM. So include everything and define now stdlib, so it doesn't include stdlib, and yeah, right. And then this part, which I mean, we can go over the JavaScript part first. Maybe it's gonna be maybe it's gonna be more interesting. So for the JavaScript part, I had to manually parse the format string and decide, oh, it's an S, then we have to put a string, it's a D, we have to put a number. So that was the idea of parsing the format string. So let's actually I guess talk about JS format, which is a function that I added on top of what we had last time. So this one is supposed to be similar to VS and printf, and if you know from this.h, I guess inside of let's actually search for VS and printf. Yeah, so inside of string builder append, if you remember from a few videos ago, I guess, when I said that, oh, because we have variadics here, we cannot really port this function or like compile this one to WASM because it uses VA list, and this like VA list, VA start, VA end, these are all included only in stdlib. So this function won't work if we have stdlib enabled. So we can only include this one, this definition of this function, only if we don't have stdlib. So yeah, we cannot compile to WASM with this kind of parameter here. But I mean, in the end, after printf debugging and doing stuff like that, I figured that this thing, it's going to be just a pointer to the stack, right? So if you know how the arguments are sent in like assembly for C code, you know that usually you just do push and you push them on the stack. So this is gonna be like a pointer to that first item, right? And I guess how does this thing know which is VA end? Not really sure, but in the end, this thing is just a pointer, right? And the way I guess printf figures it out is, let's just add a printf somewhere. I mean, we can do it here. So the way the printf does it is it also parses the these these things, this %d, %s, and so on, and it counts your arguments. So it says, okay, I found this thing, so I expect one argument. Then it counts the next one, it expects another one. And if you have not enough arguments, then it's going to say, oh, I was expecting one more argument. Where is the argument, right? So that's how it knows how many arguments it needs. But yeah, I mean, in this case, not really sure, but shouldn't matter. Right, so this was the initial problem that we had. We couldn't compile this thing to assembly because it is based on stdlib, and that doesn't work. So I made use of macros actually to define an implementation for this function, right, when we use WASM. And this implementation uses the va args define, which actually this one doesn't use stdlib, which is kind of weird. Why doesn't it use stdlib? It's pretty strange, but it's just a macro that expands these 3 dots. So I guess that's pretty cool because we don't need to implement it using like C code like here with va list and va args. We can just use this macro and it's the same thing. But the only difference is that this now it's a define instead of a function, which it's kind of ugly, but still works. So yeah, that's I guess the main point. You cannot really use va start or va end with variadics. You have to use this define if you don't want to include stdlib. And this was the part that was the like trickiest for me to figure out like yesterday. But other than that, that was like the only thing, right? JS format is an external function and it's going to be called from JavaScript, or like it's implemented in JavaScript. We can take a look at this afterwards. And yeah, then this macro works exactly the same like here. So you can see here it does vsn printf. Here we do the same vsn printf but using the JavaScript implementation. Then we do a malloc for our buffer. Then we do another vsn printf call to actually populate this allocated buffer, right? So the first call gives us the length because we pass null, and the second call actually fills in the memory. And I mean, I know we have to do these 2 calls, which is annoying, but it is what it is. Like we need the memory to be allocated to write into it because otherwise it doesn't work. It's like C, right? And then we add an extra 0 at the end. I don't know, do I do that here? I don't think so, but since we allocate extra 1, it's fine. And then we use dynamic array append many, right? We use the, I mean, string builder is just a dynamic array. If you are confused about this one, it's a dynamic array of characters. So we just add all of these characters into our string builder, and then we do, I guess it's this free right here, right? Yeah, it's the free for the buffer, this buffer, right? So that would be like, okay, we had to re-implement this function by using something different than vsn printf, and we could have, I guess, you know, if va start and va end worked without stdlib, we could have just said, okay, instead of vsn printf, let's just use JS format, right? And this is the same thing, but yeah, this va start was the problem. And my other approach to make it, which was a bit clunky, like it needed so much code to like boilerplate, was that instead of 3 dots here, I was thinking, what if I just use an array? But then you have to build the array, you have to like use for loops and stuff. It's like, it would be ugly. But yeah, let's take a look now at JS format. How does it work? or how it's implemented rather. So JS format, it's here. So first of all, I have these parse cstring, parse int, parse whatever functions, which are just the utils that use the memory, or the W instance use the memory, and then they just read from that address from this memory, right? And the memory is just an array of uint8s, so array of characters, right? And in this parse cstring, we are just iterating the memory until we find a 0, which is the null byte at the end of the string, and then we just slice the memory from the start to start plus length, and we read it as a string. So that's how we get a C string into a JavaScript string. Obviously we have the reverse, which is dump C string, and this one takes a string, JavaScript string, the address where we want to write it, and we use this memory.set, which sets a string. This is the starting position, and because it's a string, it knows the length, it knows how much to write, but we also have to not forget about the 0 byte at the end of the string, because it's a C string, it ends with a 0. That's kind of interesting. Then we also have this parse int function, and here you have to be careful about the NDNS, and since WASM is 32-bit, we only have numbers that are 4 bytes long, 32 bits, obviously. And yeah, we have to be careful about the fact that this is little endian. So if we try to read a C string, a C int, sorry, into a number, we need to take the least significant byte and put it first, right? So from the least significant, it becomes the, like, it's not right to say it becomes the most significant, but it becomes the first byte, kind of. Anyway, and then we take the second one, third one. So this is basic C, like bit work, right? We are just doing some stuff on bits. Here it takes the first one and it shifts it to the left 0, so it's like the original one. Then it shifts the second one to the left by 1 byte, the third one by 2 bytes, and the fourth one by 3 bytes. So you can see that it like if the number was, let's say, in memory 1 2 3 4, it kind of converts it to 4 3 2 1, right? And it's also using ORs, so it's but I mean, it's not 4 3 2 1, but yeah. So it's like doing a instead of bar you could do instead of pipe you could use a plus, but yeah, whatever. And dump cint is doing the same thing, but kind of in reverse. So it sets the first, or like the least significant byte to the first byte from the value. That's what this well, here maybe I could have said something like this to make it more how can I say it, how more like looking the same, right? They look kind of similar. So now you can see that here we shift to the left, here we shift to the right. That's the difference. So we take the first byte and put it last, then the second byte we put it second to last, then this becomes second and this becomes first. Okay, so that's kind of the idea with these, parsing from the memory and writing into memory. We need these functions. Okay, and then if we go back to JS format, we have to parse a C string for the format itself. So the format itself is, if we go back to just C, is this part, which contains the %s, %d, and whatnot, and we read it into a JavaScript string, right? Then we have the final string, which we use format string for. We look into format string, and if the buffer address is not null, so it's different than 0, and you saw in wasm.h that first we send null and then we send a non-null buffer. So if it's null, we just return the length. If it's not null, we also write the final string to that address. All right, so let's see how we build that final string. I mean, it's kind of annoying that we have to build the final string twice, and that's why I want to change log c string, because probably we don't need to build the buffer and then print. Most of the time we just want to print some info and be done with it, so it's going to be just one line. So that's why I want to make it simpler, to just call to c string, log c string. But yeah, let's see how we use format string. So the implementation, pretty simple. We start with an empty string, forgot the semicolon, but that doesn't matter. We have the address of the rest of the variadics, and as I said, this is just a pointer to the first element in that list, right? So I created another variable called arg address, which makes you think like, okay, this is the first argument. It's exactly the address that we sent. If we look at, let's look, I mean here at WASM, you can see that we pass these VA args here, so it's the address to this thing, right? So we iterate the format string, and if we find a percentage, then we are interested. Is it gonna be S or D? So if it's gonna be an S, we have to parse the, so now it's also a bit interesting. We have to parse from that address an integer, right? And that integer for strings is going to be the address of the string. So I kind of got this thing by trial and error. Like first I thought, okay, let's just use parse string. It didn't work. I said, what if I parse an integer before that? And then it worked. So kind of got lucky here. But the idea is, this argument, obviously it makes sense that it's a pointer to something, so it has to be, we have to parse an integer first, and we get the pointer to a string, and then we just read the string from there. And for the number, it was actually saved just like that, so we don't have to parse anything else. We just parse the integer. Okay, and then we have to advance the address by 4, because again it's 32 bits, so we advance just by 4, and we get the second argument. But again, here you can see that this format string function, that doesn't really check if your arguments are correct. Every time it finds a percentage, it advances the address. So if you put like percentage, I mean, whatever, it's kind of cooked, but you get the idea. If you use %s, then it parses this correctly. We'll probably have to add more things here, like if you use 2 percentages, then it's just a single percentage, so you don't have to do this stuff. But no, otherwise, yeah. And then we just add a character. So that's the idea with this format string function, right? It just parses the format string. If it finds a percentage, it looks at the rest of the arguments, which come in order. Obviously it's on the stack, and yeah, hopefully it makes sense. So what I wanted to do now is to add kind of the same thing here, but just by doing this. So implementing log C string, kind of using the same theme, right? So yeah, hopefully it's gonna be useful. So if we go back to the JavaScript world here, we should add a REST address number, right? But right now REST address is not used, so what we have to do, I guess it's just call, let me just here format. I mean, it was obviously easier than expected, right? So it's just calling to format string, but obviously we have to fix format string in the end to work with like, I know there is a library called something like snprintf JS or something. Yeah, this one I think. Maybe not. But you know, there are for sure libraries in JavaScript that work like sprintf or you know printf. Yeah, this one I think I saw yesterday. But the problem with this one is it doesn't know that it needs to do this parse string or parse int or parse whatever. It only yeah, like it's kind of weird, right? We have to do our own parsing for this thing to work. So that's the only problem. But anyway, so let's see if log C string works now as expected. So if we go to chess.c, what if instead of printing the buffer, we just say here hello from %s %d, and then we do Java script and then 69, and we rebuild this thing. Gets no errors. Kind of broke. I don't know why if I because maybe it wasn't loaded, maybe it was cached. So it says hello from JavaScript 69, right? So it's and now it's even shorter. You don't even need to add all of these string builders, which is perfect. All right, we don't even need, I mean, JS format, sure, it's useful, but log C string is gonna be much more useful for us because we'll be able to do stuff like, let's say here we want to JS log this string selected is at %d, right? And then we just do select, oops, select dot row, select dot column, and that's that. Now we can literally print stuff from C right into the console of the browser. So if I click on this thing, selected piece at row 1, column 3, and that's really is going to be really useful, right? Being able to see this information, being able to, because you know, if you know me, I really like printf debugging. It's like my favorite thing to do. Move piece, and then we just say select, right? Again, like if I cannot printf debug, then for me it's GG's, it's over. No, I should use the other it's square, right? I think it's square. Select is the one that I move, and square is the where I move it to. Okay. So if we refresh the page, okay, now let's attack with the king. Okay, interesting. So now we have printf. Perfect. So obviously the next step would be like chess related, making the moves work and stuff like that. So yeah, maybe I'll handle that myself, and then we can look into more WASM stuff. So yeah, I guess that's it for today. Hopefully it was interesting how we managed to get this log string part. Obviously, I'd like to update this format string a bit more, make it more like I'd like it to support more of the printf stuff, like being able to print left pad and stuff like that. But we'll get it as we go. So if we find a new feature that we need, then we'll add it. I think that's the best way to do it. So yeah, thank you for joining today, and see you next time.